Welcome. Today we're going to talk about why people are interested in the bioeconomy. And we're going to focus on inputs. What do we need as inputs to the bioeconomy? Okay, so our learning objectives. For any of society's needs, we want to know what are the inputs that we need in order to meet our needs. And then we want to look at some various inputs and try to understand, positives and negatives. And then we want to develop a general understanding of what goes into bioproducts. Okay, the first thing we want to talk about is raw materials. There's lots of different categories of raw materials, and you can break it down into construction materials, industrial, minerals, metals, and then organics. Some are for like petroleum, coal, and natural gas that are non-renewable. And then you have renewable organics like agricultural biomass and forestry biomass. All these things have pluses and minuses, and they're used for different applications in different quantities. This graph shows really how much materials we actually use. What you can see is that from 1900 to 2014, that's the x-axis of the graph, we have incredibly started to use and consume large amounts of raw materials. You can see that growth that occurs around 1930 or so. And what you see is that it's really dominated by construction materials and industrial minerals. On the inset from 2000 to 2014 gives you a little expansion so that we can kind of see how renewables are contribute to all this. And what you can see is that there's a small percentage of our materials are wood and paper, the green and the blue at the bottom, right here and here. Recycled paper in white, that's actually a big contributor in the grand scheme of things for recycled materials. But it's just a small portion of all that we use. Okay, one thing to realize is that back in the 1900s and before that, we were using quite a bit of renewables, a lot of wood and agricultural materials, and that has shrunk, mainly due because of the convenience and the advantages of petroleum-based products. So if you think about how much raw materials a person uses, this cartoon shows us really some significant examples of how much the quantities we're going to use over a lifetime. What you can see is that we use a lot of input materials, and the ones that are highlighted with the blue squares are non-renewable. And what you can ask yourself is, could we replace these with renewable materials like biomass, plants and animal-derived materials to replace some of the non-renewable material? Okay, so when we think about raw materials, we have to consider their life cycle. So the life cycle looks at all the different stages of something and tries to understand from a holistic view what are the impacts, let's say, to the environment over its entire life. So if we talk about raw materials, what we have to start to think about is we first have a resource supply that might be in the ground or in the water, and we have to mine that. And then after that, we do production and manufacturing to get these raw materials into a suitable form for further processing. And then finally, we have the consumption. And the consumption is where we take the raw materials and we actually put them in a product that we can use. Now, what you have to think about is there are impacts of those things, but then also the waste and byproducts that come from all these processes. So we can talk about when we produce, manufacture, or supply these raw materials, we get wastes or losses. And there's kind of two avenues. There's the reuse and recycling avenue that is very good in many cases. And then we also have the just kind of final fate where these things might go to landfills or the ground or air or water. And one of the things to think about is that if we put plant material, bioproducts into the ground or air or water, they degrade, they get incorporated into the soils and water, and then they can be used to renew new bioproducts. So that's an important differentiation between bioproducts that are landfilled, go into the environment, and other non-renewables like plastics that don't get reincorporated into the environment and made into new plants. Okay, some of the other inputs that we need to talk about are energy inputs. And when we talk about energy inputs, you should just appreciate that there are really two broad categories, non-renewable and renewable. So non-renewable means that we're taking it from the environment and we're not regenerating it at the same rate as we're taking it. Renewables, on the other hand, are regenerated at the same rate. So that's one of the primary important differences between the non-renewables and the renewables. But you can see on the left we have non-renewables like oil, nuclear, coal that are being used up. And there's just a question about how much quantity do we have left and will we have that in the future. On the other hand, the renewables, and it's interesting, you can see a lot more blue skies in those. We in general feel like they have better environmental impacts and that we won't ever run out of these if we use them in a wise manner. So for instance, biomass, we can grow new trees just as fast as we take them down in many cases, and so it can be sustainable. When you think about energy inputs, you have to kind of think locally. Different parts of the United States have different energy uses. So in the Northwest, we primarily have hydroelectric, which is actually very clean and doesn't have that much emissions. In the Midwest, we've got a lot of coal. In the Southeast, we have coal and nuclear. Each one of these has unique pluses and minuses that we have to think about in these local areas. So when we talk about energy consumption, let's just kind of understand how big renewable energy is with respect to all the energy that the United States uses. Currently, we've got about 10% of our energy needs met by renewable energy. So it's a small part of the pie, but it's growing, and it's very important because it should hopefully in the future replace some of the other non-renewable sources. From that pie, the renewable energy, what you can see is that biofuels here is about 22% of that. So 22% of about 10% is about 2%. So 2% of the entire U.S. needs for energy are coming from biofuels. Another 2% approximately are coming from wood. That's important because we really feel like we can renew those. We have smaller components of geothermal and solar, and then wind is also significant, about 2% of our total energy met by that. And then hydroelectric, again, about 2%. So when you think about all these energies we talked about, renewable and non-renewable, what you have to think about is the pluses and minuses. So renewables and non-renewables both have pluses and minuses, and really when you analyze them, you need to think about that. For instance, coal. There's lots of advantages. It's low cost and it's abundant, but when we combust it, we put carbon dioxide and other emissions to the air, and that could be a problem. Again, petroleum, non-renewable, but we can make a lot of different products from petroleum. We make gasoline, we make diesel, we make waxes and plastics, all things that are high value and society needs. But on the other hand, this can be very expensive. If we have spills of oil in tankers or things like that, there can be some damage. And then, of course, it's non-renewable. Natural gas is another one. Is very low cost, abundant, and actually it burns pretty clean. And so it's effective, cost effective. However, there's issues. Now we're getting the natural gas from deep in our ground. We're doing fracking, and then there's questions about whether this gas is leaking into our drinking water. Nuclear, again, not a lot of emissions, so there's a nice positive there. But the problem is that you have this radiation, you have the risks of problems in the nuclear plants. Solar energy, of course, that has really no direct emissions. and it's definitely renewable, but the problem is it takes energy, and it also takes a lot of different chemicals and things to make these solar energy panels. We'll talk about that next. And then you have geothermal and wind. These things are low cost, but they're intermittent, which is another energy supply problem, because we want to have a constant, dependable sources. And geothermal and wind, they might be locally limited or intermittent with the wind. Same thing with hydropower. Different. Let me start over. Hydropower is low cost, it's renewable, has no emissions. The disadvantage is that it changes the landscape. It takes land and it covers it with water, typically with a dam, and really changes the ecosystem. That's the disadvantage. And then, of course, biomass is the one that we really are excited about and focused on. Biomass is abundant. It's renewable, we can grow it back, and there's a lot of energy storage that we can keep in the forests or fields. There's a lot of pluses. Another plus is that biomass takes up carbon dioxide from the environment. So those are all things. There are some negatives. There is some land take, which could be plus or minus, and then uses a lot of water, and it can use some fertilizers and energy. Just as an example, solar panels. We think of solar panels as having no emissions to the atmosphere, which is great. But the other issue, if you think about it with the life cycle analysis, it uses a lot of different metals. And some of these can be rare metals. On the left, the graph shows you the abundance of metals and their cost. And some of the more rare metals can be very, very costly. On the right, it just shows you the production of elements that are necessary for the solar panels. And so it's very significant that we're using these non-renewable resources for this quote-unquote renewable energy source. Another example is batteries. Batteries can store energy for a while, and that is effective. You hear a lot of talk about electric cars. However, they have their inputs that can be problematic too. So, for instance, batteries use cobalt, and cobalt can be sourced, is sourced quite a bit from the Republic of Congo. And there's quite a bit of issues with labor practices and fair trade and things like that. Those inputs to batteries are very contentious. Okay, so now let's just kind of talk about inputs that go into bioproducts. Well, the first thing is land. And like I said before, land can be a positive or a negative thing when you talk about bioproducts. In general, we think of land take as important and positive when it comes to bioproducts. In other words, with valuable bioproducts, that makes growing biomass more valuable, and the value of the biomass goes up, and then for that reason more people will want to plant forests or crops. And that is, we think, a positive thing because it takes in CO2, and then forests are very important for ecosystems, for filtering water, for doing a lot of things for society. And so we really want to encourage all this. So the land take for bioproducts is really a positive thing. The other thing that bioproducts need as inputs are energy. So energy can come from direct things like you might imagine, like a tractor and the diesel that it uses, but a lot of the other things like fertilizers, irrigation, distribution of these materials all require a lot of energy to produce, and those go into the biomass. So biomass isn't scot-free. We do use energy, in some cases non-renewable energy, but the net, we hope, is going to be higher. Net positives are higher for bioproducts. So really, how much energy does it take? In general, like agriculture can take a lot of energy. This statistic is showing that about 1.74% of all of the U.S. energy consumption is used by agriculture. So the energy can kind of be hidden. A lot of the energy goes into making the fertilizers for applying to crops. There's energy in diesel for the electricity we use, the natural gas we use, pesticides, and others. So the energy use is spread out amongst a lot of different things that the bioproducts might need. One thing that we like to talk about is the difference between forest biomasses and intensely managed crop biomasses. And this example right here comes from a life cycle analysis. And what it does is it kind of compares differences in energy inputs and other input materials into forestry versus crops. And what you'll see is that the forestry for harvesting uses a little bit more fuel, maybe twice as much fuel, but fertilizers and herbicides are much, much lower for forests. In other words, the chemicals that are applied are much lighter. So that has some significant advantages to forest biomass relative to agriculturally grown biomass. Now, the other input that is very, very important in bioproducts is water. We take water from a lot of different sources, and so in the upper left-hand corner you see that we can pull water from below the ground or from rivers or lakes on the ground. On the bottom left, it's just showing you the withdrawals of water for different states, and it varies very much. For a lot of these states that are intense, the darker blue indicates that we're consuming with water withdrawals of about 2,000 to 6,000 gallons per day. 2,000 to 6,000 million gallons per day. That's very, very significant. The upper right shows kind of some places where we can get water, the aquifers that supply us water, and some of these sources are under a lot of stress. So the one here in the Midwest right here has been a source of a lot of controversy and issues with respect to is it really renewable and sustainable to take the amounts of water that from these water sources in that area. And then the other thing to think about is that water is not always abundant at the same level in different parts of the United States. So the bottom right graph shows some places where there's intense precipitation, raining, in dark blue, and then there's other places that have very little rain. So not every place is blessed with the same amount of water sources. This statistic is just a little bit interesting. We don't really think about how much water we use. We take showers and drink water, but that's not really all of it. 96% of the water that you actually use is kind of hidden. It's hidden in the products that you use and some of the activities that you do. So really, when you kind of tabulate it all up, each person uses about 750,000 gallons of water per year. That's pretty amazing. This graph kind of shows that some of the biomass products that we're using really consume a lot of water. It just gives you an example. So the one I want to point to is cotton. If you use cotton to make a t-shirt, only one t-shirt requires 700 gallons to produce the cotton and then make the t-shirt. That is really significant. So that's a great example of hidden water use. Okay, let's talk about hamburgers and delicious things that we eat. As an example, a hamburger has a lot of inputs to it. For instance, for just one small hamburger, you're using 6.7 pounds of grain. So 6.7 pounds of food to get maybe a quarter-pound hamburger. Amount of water, 53 gallons per one hamburger. Land, lots of 74 square feet. So a lot of that comes from grazing the animals and growing the crops to feed the animals. And then it takes a lot of energy. So on the right, what we are doing is showing an example of a contrast. You can get protein from soy plant, and you can get protein from meat. And so in this graph on the right here, 1 pound of soy is going to take about this much inputs, okay? Now, if you contrast that to 1 pound of meat, these are the amounts of inputs, where each one of these symbols is kind of is proportional to how much it takes. So basically what we're seeing is that we're using about 12 times as much land, 13 times as much fuel, and 15 times as much water to make a pound of meat as we do soy. So that's one decision that you can make that really has an impact. And to think about it, if you think about the entire globe, 30% of all land is used to raise animals for food. Very interesting. That's a decision that society and people have made to live, and it has certain consequences. Okay, let me just kind of summarize at this point. We reviewed about raw materials and the energy inputs that are required that society needs for our living. And then we also discussed some of the pros and cons associated with various energy inputs. And in fact, one of the things that I tried to bring up was that renewable and non-renewable both have positives, both have negatives, and we have to kind of look at the whole picture and try to understand what's going on, not just look at one little dimension. And then finally, we reviewed the major inputs required for bioproducts. Land is an important one, water is another one, and energy is another one. And of course, we use chemicals and things too. And that concludes my lecture.